Mr. Harris here, and welcome to a new video of Unit 11. In this video, we're going to talk about how metals react with water or steam. So in the previous video, we talked about how certain metals, those that are more reactive, they're able to react with water, which is in liquid state, or they're able to react with steam, which is in gas state. And this is for metals that are a little bit less reactive. So let's look at the first group. The first group of metals, the ones that are more reactive, highly reactive, usually it would be potassium and sodium only, right? But for this particular reaction, calcium joins the party. So it's these guys, these metals, the first three. So they're able to react with water. Sometimes they call it cold water, just to amplify the meaning of water, that it is in liquid state. So even if you just write water, that will be totally fine. Now the second group of metals would be from magnesium all the way to iron. Right, these metals, they're able to react with steam, which is in gaseous state. And then the last group of metals, lead all the way down to gold. These metals, they are unable to react with neither water nor steam. So there is no reaction. Right, so we'll be only focusing on the first group of metals that are able to react with water and the second group of metals which react with steam. All right, let's look at the first group. Potassium, sodium, and calcium. What color did I use back there? Okay. Metal plus water, you get metal hydroxide plus hydrogen. This is the word equation. For example, you have sodium. When you add it into water, you get sodium hydroxide plus hydrogen. All right, 2 pointers over here. First off, we'll be using word equations a lot in this unit, so please do not mix them up. Second thing is, I noticed some of you might leave out hydrogen in the word equation. So remember not to leave this out. And one more pointer. Sodium hydroxide, is it an acid or an alkali? Yes, it is an alkali. Or you may also say alkaline. They're the same basically. Right? So some observations, just like how we learned in when metal reacted with oxygen, certain metals will give off a color in the flame test, right? Same thing over here. When you put these metals into water, they usually will form a silvery ball that moves around the tray of water. It moves around in circles because of the vigorous reaction. And also you'll notice there will be a color flame characteristic of that particular metal. Moreover, calcium, because it is less reactive based on the metal reactivity series, so the reaction with water would also be less vigorous. So you can imagine the metals that are on top of the metal reactivity series, they'll have a more vigorous reaction, but as they go down below the metal reactivity series, the reaction would become less and less vigorous. So some observations over here for these metals. By the way, these observations, you do not need to memorize all of them. You just need to know one or two of them will be totally fine. Especially some of them are quite repetitive. For example, you've already learned potassium burns with a lilac flame, sodium burns with golden yellow flame. You may also, for this particular reaction, you may also mention that they melt to form a silvery ball. That will be perfectly fine. So on the right over here is the experimental setup. So if the question asks you, can you draw the experiment setup? This is what you'll be drawing for this particular reaction. So over here you have a bunch of calcium metals. And of course there is water inside. So there'll be a reaction forming calcium hydroxide, and hydrogen is also being formed. All right, let's look at the second group of metals, those that react with steam. So it is magnesium, aluminum, zinc, and iron. Because they do not show, or they show little reaction with water, so instead they're able to react with steam. Now the reason behind is because steam is at a higher temperature, so a higher temperature would usually mean that the reaction would be able to occur for these type of metals. However, the word equation is a bit different now, guys. Pay attention. Metal plus steam, you would get metal oxide instead of hydroxide. So this time you get oxide. For example, magnesium plus steam, you would get magnesium oxide plus hydrogen. So another one could be you have zinc plus the steam, you would get zinc oxide plus hydrogen. All right, the experiment setup would look a bit different. So the experiment setup. So again, if the question asks you to draw the reaction of these metals with steam, this is what it will look like. So you have a metal over here. Oops. You have a metal over here in the middle. And then there is steam being provided on the left over here. You have a delivery tube over here because you want to collect the hydrogen gas up on the test tube over here. Right? Of course, there will be a metal oxide being formed as well, but mainly this is done in the lab, in the school lab, so it's a bit simplified over here. Again, observations, you may just know a couple of them. For example, magnesium produces a very bright white light. Also, this was mentioned in the previous video when we learned about metals reacting with oxygen, and the rest you can read them by yourself. All right, let's do some questions now. Calcium reacts with cold water to give a gas. In a certain experiment, a student added some newly bought, okay, calcium granules into a beaker of cold water. So calcium granules, you may just consider them as calcium grains or like calcium small solid metals. Write a word equation, well, that's very simple, for the reaction between calcium and water. So the word equation, guys, so let's look at question B at the same time. Draw a label diagram of the setup carrying out the reaction of calcium with cold water in a beaker. Okay, so they're asking us A, word equation, B, label diagram. So if we go back, calcium, the label diagram is over here for question B, and the word equation is over here. Fairly simple, right, guys? So most of these questions, they'll be either asking you word equations or drawing label diagrams. So make sure you're familiar with these question types. So question A, calcium plus water, you get calcium hydroxide plus hydrogen, no problem. And you can just redraw the experimental setup. Let's see question C. The student added a few drops of universal indicator to the content of the beaker after the experiment. State your expected observation and explain your answer. Alright, so I've been teaching this to my Form 2 students. Universal indicator, do you guys remember what it is? It's been like 2 years. But universal indicator is an indicator to indicate whether a solution is acidic or alkaline. So in this case, I think I mentioned this earlier in the video. Calcium hydroxide is it is an alkaline. So what would be the color of the universal indicator? So if it's an alkaline, guys, it would become blue in color. If it's acidic, say for example, if there is an acid present over there, the universal indicator would become red. Right, so the universal indicator changes to blue. This is because calcium hydroxide formed is alkaline. Now let's look at question D. Suggest 2 potential hazards in performing the above experiment. So this would deal with book 1A. So we already learned that hydrogen gas is explosive or flammable, so that's a potential hazard. You may also mention that because alkali substances, they're corrosive. You can also mention that, and also heat is released in this type of reactions, so that is also one hazard. Or any other acceptable answers, that would be fine, but mainly these three are very common. Finally, let's look at question E. The student repeated the experiment with the same mass of an expired sample of calcium granules that had been exposed in air for a long time. Suggest why less gas was collected in this second experiment when compared to the first one. Also, this has to do with what we've learned in the previous video. That's very, very good. So do you guys remember what happens when we have a metal? This is a metal, right? And it is exposed in air for a long time. In air, we have oxygen. So what would happen? A metal oxide will be formed, right? In this case, calcium oxide. So when an oxide is formed, what happens? It forms the oxide layer, which covers the metal, right? And remember we said why metals have a dull color? It's because of this layer. So also because of this layer, it covers the surface of the metal. So the the reaction will not be able to occur as smoothly as the original experiment. So let's have a look. The surface of the expired sample of calcium granules had been exposed by air, so meaning there was a reaction with oxygen. Thus, calcium oxide was formed and less calcium reacted with water to form the hydrogen gas. Alright? Makes sense, right? So now let's do a quick wrap up. So this was on the reaction of metals with water. The first group of metals, let's use purple. It was potassium, sodium, and of course I mentioned calcium joined the party today. So I'll just write down the word equation. So metal plus the water, which is in liquid state, you would get metal hydroxide plus hydrogen. Don't forget about hydrogen. The second group, let me use green. From magnesium all the way to iron, they're able to react with steam. So metal plus steam, which is in gaseous state, you would get metal. This time it is oxide plus hydrogen gas. Okay, you do not need to write liquid or gas. I'm just writing it for our sake. And finally, the last group, there is no reaction. Alright, so that sums up our video for the reaction of metals with water or steam. So I'll see you guys in the next video. Bye for now.